Assalamualaikum warahmatullahi wabarakatuh. Hello, Mr. Omar. We are from Group 4, and today we are going to present our topic on what is a system and what is model. My name is Faiz Rafi Darmanto. So, for today's presentation, first of all, we're going to talk about the system, and then we're going to talk about the model and briefly on simulation. So, what is a system? A system is basically interconnection between variables and factors that usually achieve a common goal. A system usually have the characteristic of it being complex, and the variables and factors within the system is usually interconnected and it is usually organized. The English Dictionary defines a system as a complex whole or a set of connected things or parts. So within the type of the system, there is actually three main parts. That is the engineered system, the socio-politic and economic system, and the natural system.
Okay, my name is Muhammad Nazifka, and I will continue about this types of system. So the first is the engineer system. It is basically system that is contained of man-made materials or factors. The example is chemical plants and telephone system. Um, and the other side is the natural system. It consists of maybe living or non-living natural factors. For example, for living is human beings, and for non-living is solar system. Between those extreme system, there's something in the middle called social, politic, and economic. And the example is government and university. As a system is leaning towards the left side of this chart or into engine system, it becomes more centralized and rigid. On the contrary, if a system is leaning towards the right of this chart or into natural system, the system is becomes decentralized and evolutionary. Next. For this presentation, we take an example of airport, specifically about plane gates. So this is an example of a engineered engine system. And if we going to explore or study about airport, the system of airport, it will be really hard since it has strict schedule and really big scale of observe. So we need something that would easier for make us easier to study about airport. Next.
Okay, we continue. My name is Muhammad Rijal Alfat. Now, after we know about the system, we can now move on how to turn into a model. Okay, first of all, what is a model? A model is a representation of the construction or the working of some system of interest. A model is similar to, but more straightforward than the system it represents. Meanwhile, the Oxford English Dictionary defines it as a simplified, often mathematical, description of a system to assist calculations and predictions, which fits well with our system perspective. Okay, so now we basically by having the model of the system, we can conduct the simulation itself. Next.
To continue from our part, let me introduce myself. My name is Cahya. To make a model from a system, first we must understand the system by analyzing its process, its factors, and variables that connect it to each other, and the problem that we want to try to be solved. Second, we must determine the model constraint and boundaries so that we know what cannot be done in the model. In other words, we must make the rule of the model. Next, we have to map the model by determining the sequence of systems. Then on the next step, we can make the model. Finally, so that other people can read and analyze the model, we must make an interface for the model so that we can share it with others. Next, there are different kind of models. The first one is the mathematical model, the first type. The mathematical model use symbolic notation and mathematical equation to represent a system, and it is usually called the simulation model. Such as the Monte Carlo simulation, for example. The next type is the physical model, or it uses a larger or smaller version of an object to try to enlarge, for example, an atom or a scaled down version of the solar system. Next.
Okay, another representation of a system is a mental and conceptual model. A mental model is the representation that a person has in his mind about the object he is interacting with. However, the conceptual model is the actual model that is given to the person through the design and the interface of the actual product. Next. And here we have the example of the model of the system of the airport plane gates. So now we have the model and we know how to make the model from a system. We can now continue on how to simulate the model itself. Next.
My name is Devin Muhammad Hanif, and while we are in the topic of systems and models, we're going to talk briefly about simulation. In definition, simulation can be understood as an estimate of representation of the operation of a system or a process itself. And its purpose is to make us understand more about how a system or a process works under a certain situation, meaning the behaviors and the mechanisms. And simulations can be as simple as video games, 3D animations to, let's say, production line simulations. There are four leading types of simulation. Number one being Monte Carlo for risk analysis. The second is agent based for focused agents inside the system itself. And the third is discrete event simulation for discrete events. And last but not least is system dynamics for focusing on broader entities on the system itself.
Okay, next. Okay. My name is Andi Muhammad Rifki, so I will continue to explain about simulation. So, why do we need simulation? So, simulation helps us in capturing the system independencies, provides information on multiple performance measure, and also provide us results that are easier to understand and communicate. Okay, next. So, to understand it more easier, here's an example of simulation, which are airport simulation. But this example is kind of hard, okay? So for easier understanding, let's use the flight simulator as our example. So flight simulator can be considered as SSG or serious simulation game, which outcome are based on what we input while considering uncertainties. Okay, there are many factors, or you call it input, that could lead the airport to different outcome. For example, planning and allocating personnel to procuring and maintaining vehicle fleet. The gas fuel each plane have also is an input, facility maintenance, and also handling large aircraft. Each of these factors contribute to the outcome of the game. So, after considering the input and outcome, we will have better understanding of the system from what we simulate. The simulation will help us to decide better input for the airport, and also it will lead us to a better outcome. Next. So, we have reached a conclusion, which are model acts as a representative of a system or process, and with simulation, we could freely test and analyze the system without disrupting or creating a system. Okay, that's all of the presentation. Thank you for your attention.